All right, in 6.1, we are going to start looking at trigonometric identities. Now, we've already started working with these ones on the left side. Okay, we've talked about how sine and cosecant are reciprocals of each other, cosine and secant are reciprocals of each other, and tangent and cotangent are reciprocals of each other. Okay, and remember, we said the way to remember that is there is one co in each pair. Right? Sine goes with cosecant, secant goes with cosine, and tangent goes with cotangent. Okay. And then we also talked about the quotient identities. The tangent is sine over cosine, and cotangent is cosine over sine. Okay, we're going to use these a lot in this chapter. Now, a few new ones that we are going to use in this section are the Pythagorean identities, and we're going to go in depth with these here in just a second. Okay, but the main one is sine squared plus cosine squared equals 1. Some other forms of that, which I'll show you how we derive these forms here in a second, are tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. Okay, so the goal of this section is going to be to use these identities to simplify and manipulate expressions and equations. Okay, so first, let's discuss where these Pythagorean identities come from. Okay, so if we look at the unit circle, okay, and if we just focus on the first quadrant, let's look at the first angle that we come to, 30 degrees or pi over 6. Okay, the coordinate point there is square root of 3 over 2, 1/2. And that means that if we draw a right triangle to that point, the sides of that right triangle would be square root of 3 over 2, 1/2. And then since this is the unit circle, that means that the radius is 1, right? So that means that that hypotenuse is 1. So if we think about that first identity, and we say sine squared of 30 degrees plus cosine squared of 30 degrees. Let's find out what that equals. Okay, now I should mention another convention. Whenever we're squaring a trig function, we put, or any exponent for that matter, we put the exponent right here in between the name of the function and whatever we're taking the function of. It looks kind of strange, but that's just the convention to put the exponent there. Okay, so the sine of 30 degrees, remember that's the y coordinate on the unit circle, so that would be 1/2. So we're saying we want to square that. So 1/2 squared plus cosine squared. So cosine of 30 degrees is square root of 3 over 2. So square root of 3 over 2 squared. Then 1/2 to the second power would just be 1/2 times 1/2, so 1/4, plus square root of 3 over 2 times the square root of 3 over 2. If I square both of those, that would be 3 over 4. And 1/4 plus 3/4 equals 1. So sine squared plus cosine squared equals 1. Okay, that would be true no matter what angle we chose. Okay, if we did our 45-degree angle here and did sine of 45 plus cosine of, or sine squared of 45 plus cosine squared of 45, we would end up with 2 over 4 plus 2 over 4, and that would get us 1. Okay, that ends up being true for every single angle, okay, on the unit circle. If I square the sine value, square the cosine value, and add those together, that will always equal 1. Okay, so that is think about that as the main Pythagorean identity. The other two that are listed on the top of your paper then can be derived pretty easily. Honestly, the only one that I have memorized is this one. Sine squared plus cosine squared equals 1. I don't even bother memorizing the other two because I can derive them so quickly. The way that we derive them, okay, is we divide all three terms, sine squared, cosine squared, and 1, by cosine squared. Okay, if I divide everything by cosine squared, well, sine squared over cosine squared, we know that sine over cosine is tangent. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared, well, that would just be 1, right? Anything over itself is equal to 1. And 1 over cosine, well, that's secant. So 1 over cosine squared is secant squared. So this is how the second of your Pythagorean identities is derived. The other one we just get by dividing everything by sine squared. So sine squared over sine squared would just be 1. Cosine squared over sine squared would be cotangent squared. And 1 over sine squared would be cosecant squared. Okay, so that is the very quick derivation of the other forms of our Pythagorean identity. Okay, so the main one is sine squared plus cosine squared equals 1. And then we can derive the other two. Tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. Okay? Now, we can actually take those three identities and go even further. We can manipulate them lots of different ways, okay? And we're going to need to for the problems that we're going to look at today. Now, what I mean by manipulate them is we can add or subtract any of these pieces to either side of the equation. For example, I could take this first one and subtract cosine squared from both sides. So if I do that, another form of this identity would be to say, well, sine squared is equal to 1 minus cosine squared. Okay? I could manipulate this even further. I could then subtract the 1 over and say sine squared of theta minus 1 equals negative cosine squared. Right? So there are lots of ways to manipulate these. Okay, and I could do that with any of these versions. Right? For example, I could take this one and I could subtract the cotangent squared over and say that cotangent squared, or I'm sorry, let me fix that there. If I'm subtracting cotangent squared over, we'd have cosecant squared minus cotangent squared is just equal to 1, right? We could take this one and I could subtract the 1 over and say tangent squared equals secant squared minus 1. Okay? Now, there are so many ways to manipulate these that I'm not going to write out all the different possibilities here. Okay? But we do want to recognize that we can manipulate these. Okay? We can add and subtract pieces from both sides of these. We are going to need to do that for what the problems that we're going to look at. So let's jump into those problems, okay? All these examples on the back of your note sheet say to simplify each expression to a single trig function or number. So when we're doing problems like this, we are going to need to change pieces into equivalent forms, okay? For example, on this one, okay, I know that cotangent is equal to a few different things. I know that cotangent is equal to 1 over tangent. I know that cotangent is equal to cosine over sine, right? So sometimes these problems, we just want to start changing things and see what happens. But hopefully, as we get a little bit more practiced, we'll be able to recognize things that might work a little bit better. And we'll talk about some specific strategies as we go along here. But we're starting with some fairly simple ones. So here, if I change cotangent to cosine over sine, right? And I know that cotangent is equal to cosine over sine. So I can make this sine of theta times cosine of theta over sine of theta. And I know that cotangent is equal to this. So I'm allowed to change that like that. Well, now I've got a sign in the numerator and a sign in the denominator, right? Whenever I have like terms like that in the numerator and denominator, and I'm multiplying, they can just cancel out, and this whole thing would just equal cosine of theta. Okay, so those are the types of operations that we want to think about. And it tells you that your answer will always be either a single trig function or a number. Okay? In the next example, we have sine squared of x minus 1. Okay, now, I should also mention that you may see different variables inside of the trig function, right? As long as all of the trig functions in an individual problem have the same variable, then we can do these types of cancellations. If you ever see anything where these have a different variable in the same problem, then none of these properties would apply. Okay? So in this second example, we've got sine squared minus 1. Now, whenever we see any trig function squared, we really want to think about the Pythagorean identities. Okay? So sine squared minus 1, we want to think, well, is there any way that I can manipulate this to get there? And we actually already did that, right? We said it took 2 steps, right? We subtracted cosine squared, and then we subtracted the 1 over, and we got sine squared minus 1 is just equal to negative cosine squared. Okay, so whenever we see a trig function squared, think about a Pythagorean identity and see if there's any way to manipulate that Pythagorean identity with the problem at hand. So here, we actually don't even need to do anything other than say, well, we manipulated the Pythagorean identity, and this is just equal to negative cosine squared. Okay, in this case, our variable is x. All right, let's do a few more here. So here we've got a multiplication problem. Okay, well, let's start by multiplying this out, right? We'll FOIL this out. So tangent of alpha times tangent of alpha would be tangent squared of alpha. Then tangent of alpha times secant would be just plus tangent times secant. Then minus secant times tangent. And finally, minus secant times secant would be negative secant squared. Okay, so my middle terms here, I've got positive tangent times secant and negative tangent times secant, right? Even though I wrote these in the opposite order, it's multiplication, right? So these are positive and negative of the same term. Those are just going to cancel out. And I have tangent squared of alpha minus secant squared of alpha. So we just said whenever we see trig functions squared, we want to think about our Pythagorean identities. So if I go back to those, right, well, I've got one that deals with tangent and secant. Is there any way for us to say that tangent squared minus secant squared is equal to something? Well, if I take this and subtract secant squared over, we'll have tangent squared minus secant squared equals negative 1. So this one would just be equal to negative 1, right? Tangent squared minus secant squared is just negative 1. So we should put equal signs down the line here. Okay, so this whole thing, this original problem, is just equal to negative 1, all right? Our next example looks a little gross. We've got a couple of fractions. Okay, so we could, say that cosecant squared is the reciprocal of sine squared, right? So I can actually just rewrite this as sine squared of beta, right? The reciprocal of secant is cosine. So I can say this is cosine squared of beta. Well, this is just my original my original Pythagorean identity, right? Sine squared plus cosine squared is just equal to 1. So my answer here is just 1. So whenever we see a fraction like this, right, we can think about trying to see if we can just write it as the reciprocal, right? For our purposes today, okay, this is going to be the strategy that we want to use. But in the future, we're going to look at some fraction problems where we will have to get common denominators to add them. All right, let's do one final example here. Okay, this one looks a little bit grosser. All right, but in my denominator, right off the bat, I see a squared trig function. Well, again, let's think in terms of our Pythagorean identities. So 1 plus tangent squared. Okay, well, right here, 1 plus tangent squared is just equal to secant squared. So in my denominator there, I can say that that's just going to be over secant squared. Now, the numerator will stay the same for now, cosecant times secant. Well, now, since all these are being multiplied, I've got one factor of secant in the numerator and two of them in the denominator. I can cancel one of those out. So now I'm just left with cosecant of x over secant of x. So now it's probably going to be easier to think about these in terms of sine and cosine. We know that cosecant is equal to 1 over sine. So I'm going to split these up for now. I'm going to write cosecant as 1 over sine. And then I know that secant is the reciprocal of cosine. So since this is in the denominator, the reciprocal would move to the numerator, right? So if I've got 1 over secant, I can say that that's the same as cosine over 1. Okay? So now I can just write this as cosine over sine. All right. Now, as we're going, if you recognize that you can just take this to the numerator as cosine and take this to the denominator as sine, you can skip this step and just write it like this. Okay. But for now, I would recommend writing these out like this. Now, this is one of our quotient identities. Cosine over sine is just equal to cotangent. Okay, so that would be my final answer. We've got it down to a single trig function. So this whole mess at the beginning was just equal to cotangent. All right. Now, I should mention that for these types of problems, the work is your answer. Okay, the work is your answer. So when we have a quiz or a test over something like this, it will be on paper because what I want to see is your work. All right, I want to see your process to get here. Now, as we get into ones that are a little more complicated later on, there are plenty of different ways that will work, right, to get to a final answer, which is why the process is so important. All right, so that is it for this video. The final question is going to pop up asking you what questions you have.